Alright, well, we're looking at 8.1 and Algebra 1 here, guys, and I want you to go ahead and get started at the beginning. Go ahead and skim the lesson, predict two things that you expect to learn based on the headings and figures in the lesson. So pause the video, go look at your textbook, and fill in these two areas right here. Next, we're going to look at the active vocabulary. So these are all new things. This is a new section, this chapter 8, where we're talking about something called polynomials. Polynomials, you'll see it's our first term, and all of this is right here in our book, so you can see everything right here, polynomials, and it kind of breaks it down for us. If you like to read through that, you can go there. That's on page 491. But I'm going to break it down for us here. A polynomial is a monomial, or the sum or difference of monomials, each called a term. You're like, oh man, what's a monomial? Where did I find out what that is? Okay, a monomial is just like an expression. So that would be like, a monomial would be like 7x, or even 7x squared, maybe even negative 4x to the fifth. That's one singular expression. Then we talk about binomials. Okay, that would be 2. So that'd be like 7x minus 7. Or maybe like 7x squared plus 4. Or even like a negative 4x to the fifth plus 8. Something like that. Then, as we talk about like trinomials, we typically will just, we'll talk about those. They look, many times we're going to call them polynomials. Anything over 2 will be called a polynomial, but sometimes we'll just call them trinomials, and that's 3 expressions. So that's like 7x squared plus 4x minus 2, or 8x cubed plus 4x minus 1. It could be negative 3x to the 7th minus 1x squared plus x. Something like that. It could be anything that has 3 terms, 3 things separated by addition or subtraction. And then a polynomial is anything that's more than 3. So typically you'll see it as, anything really that's 2 or more, but polynomial will be like 4 expressions in one. So that would be like 7x to the 4th plus 2x cubed minus 3x squared minus x plus 2. I don't know, something like that. That'll work. Okay, and so talking about polynomials, monomials, so a polynomial is a monomial, or the sum or difference of monomials, each called a term. Then you've got a leading coefficient. Okay, the coefficient is the first term of a polynomial when written in standard form. And standard form is being that it's kind of like how I did them over here, kind of going in descending order. So that highest ranking exponent, so you see how that's 7x squared comes before the 4. You can see that it's it comes right up here before this 4, because that's in standard form. So highest ranking orders, or the largest exponent, comes first. That's why 7x would come before something without a variable or an exponent. And like down here, I did these trinomials, okay? Again, and that's right here the highest. Then here, that's the second highest, and then over here, you got nothing. So that would be the lowest order again in the last one. 7, then 2, then no exponent. So that would be standard form. Alright, so the leading coefficient is the first term in a polynomial when written in standard form. So, like in this expression here, 7x squared. So let's see, in this expression, 7x squared plus 4x minus 2. Okay, our leading coefficient, since this is written in standard form, would be 7. Okay, and in this one, again, since it's already written in standard form, the second one here, this one here, our leading coefficient would be 8. So it's not necessarily the one in the front. It's not necessarily just because it's in front that it's the leading coefficient, but because it's associated with this largest exponent right here, 7. Okay, that would be the reason that it's called the leading coefficient. It's with that largest exponent, and in standard form it's going to be first. Pretty important as we get into more stuff, but not so important right now for your Algebra 1 and what we're going to cover. Then we've got degree of a monomial. The sum of the exponents of all the variables of a monomial. So that would be like in a monomial. Okay, what's the degree? The degree for this one would be 2. The degree for this one would be 5. The degree for this one here would be, we call it understood 1. So there's an understood 1 right here, kind of like if there were just just an x, there's an understood 1 in front of it. Well, whenever there's just an x without an exponent, there's an understood 1 right there. So the degree of a monomial is the sum of the exponents of all the variables of a monomial. So that could be seen if you're looking at a monomial that's like 7x squared y to the 4th. Okay, the degree would be the sum of these. That would be the degree, so the degree would be 6. Okay, I know that might be a little bit, again, this is kind of quick, again, if it was 7x y squared z cubed, we would add all the exponents. Remember, there's that understood 1 right there. You'd add 1 plus 2 plus 3, and that would give us the degree of 6. Okay, the degree doesn't always equal 6. It just happened that way in those two illustrations. All right, spiraling here a little bit. Let's keep it going. All right, so trinomial, the sum or difference of 3 monomials. Standard, the form of a polynomial that is written with the terms in order from greatest degree to least degree. I've already explained a little bit about that. A binomial, the sum or difference of 2 monomials, so it could be addition or subtraction. And then degree of a polynomial is the greatest degree of any term in a polynomial. So when we have degree of a monomial, of course, we talked about that right here. And then if we're talking about the polynomial as a whole, all right, we just take the greatest degree. So not just like we choose, this expression right here in the middle, so this polynomial is to the 2nd degree. No, we come over here to the greatest degree, the monomial with the greatest degree, and that defines the degree of the polynomial. Again, this is not super important for what we're doing right here, but I want it to be in your brain somewhere for whenever you get to Algebra 2 and you're going to say, yeah, I think I remember Mr. Phillip talking about this stuff. Hopefully, maybe, we'll see. Alright, from there, let's break into our main idea. So we're going to talk about polynomials in standard form and adding and subtracting polynomials. So with this first one, I want you to complete the table below for all these expressions. Okay, they give them to you, and we're supposed to label the degree, and we're supposed to define it as a monomial, binomial, or trinomial. Okay, so the degree here, this is actually incorrect. I just noticed this. The degree is 3. Okay. So because there's a 2 right here, and there's that understood 1 right there. We add those together to get the degree of 3 for this first expression. And then since it's only 1, not being added or subtracted, it is a monomial. Then we look at 4x plus 2y minus 6, and the degree is actually only 1. There's only exponent of 1, that's the greatest degree of that polynomial, and it's actually a trinomial because there are 3 different expressions. Now we've got 9x squared minus 81y squared. That's, again, the degree is 2 because the greatest one is 2, greatest exponent is 2, and that would be a binomial. So, with it being a binomial, it's just because it's separated into 2 separate terms. Maybe you'll realize that here. Let's keep going on. Alright, this one right here, it's got no degree. -7 has a degree of 0, and the reason for that is it's got no exponent. No exponent there, and no variable to have an understood exponent. So that's why it's a 0, and it is a monomial. One singular expression. Okay, again here, just realizing this is incorrect. The degree of this is 1, but it definitely is a binomial. There's only the understood 1 exponent over the y, but right here we've got 2 different expressions, 8y and then 3. That makes it a binomial. Here I'm just kind of illustrating to you know how there is an understood 1 in front of an expression without any number in front of it. With a variable without a number in front of it, there's that understood 1. Well, there's also that understood exponent of 1. That'll be important as we keep moving forward. You might remember that from last chapter. We were talking in chapter 7 about that a little bit. Now I'm going to show you a few of these, and then as we get into the practice, you'll see a few more examples. But let me just show you kind of quickly finding the sum or the difference, and we'll try to break this down a little bit better on the next couple pages. So if you don't quite get it here, don't worry too much. Hopefully I'll explain it in a little bit more detail here in just a moment. So when we add these together, we're adding 3x squared and 4x squared, and those become 7x squared. Then we've got -6. Well, you can't add that with any of those others. These are all like apples, oranges, and bananas. If it doesn't have that same exponent, it basically means it's a completely separate value, cannot be added together at all. So 8 can't be added to anything either, so it's just positive 8. Alright, let's try this again on this next one. So you've got, right here, you notice that there is a subtraction sign. Boy, that makes a big difference in this problem here. What we end up doing is kind of like distributing that negative out to these two, or you could see it as multiplying it by -1. And when we multiply this whole problem by -1, it ends up being -2x cubed and -10x, which definitely will change our answer if we're not paying attention. So when we do -x cubed minus or plus -2x cubed, we end up with 3x cubed. Then we can combine 5x plus -10x, or you can see it as minus 10x, and you end up with -5x. And there's not a third term there, and that's okay. We can end up with just 2 terms. That's perfectly fine. This next one here, you've got 4x squared plus x squared, no minus sign, so we're going to do that, and 4 plus 1 is 5. Then we go to from apples to, let's call these bananas, sure, -x plus -3x, so -1x plus -3x, or -1 minus 3, that basically makes it -4x. And then lastly, we've got positive 2 plus negative 8, or 2 minus 8, which gives us negative 6. This last one's quite a doozy here. Again, you'll notice there's a negative sign in this one. That negative sign will throw it all out of whack if you don't notice it. So again, we distribute it to everything inside of here. So we're going to say negative 1 times 1x cubed. So negative 1 times 1 makes it negative 1. Alright, negative 1, you can put that 1 there, that's fine. You don't want to make it understood, that's okay. I like things to be obvious too. Just ask my wife. She gives me all these little hints. I don't get any of them. She got to be obvious for me. You guys know what I'm talking about, right? Like, girls try to drop hints, and their hints are like super confusing, almost like algebra. Trust me. Get you a girl who does not drop those weird hints. Real obvious, real straightforward. Okay, anyways, going on from there. 5x, so negative 1 times negative 5 is positive 5. Negative times negative is positive. And then negative 4 becomes positive 4. So see, we don't really change any of the numbers, we just switch all those signs. If it's positive, it becomes negative. If it's negative, it becomes positive. Then we can add these together. So we're going to start with 3x to the 4th. Well, there's no counterpart, so it's just 3x to the 4th. Nothing to add, nothing to subtract. Then we'll go to our next one down, and we'll go negative 1x cubed, yeah, to the 3rd power. That's the same, negative x cubed. Doesn't need to have the 1, it could if you wanted to. Then the next is positive 2x squared. Well, again, we're not adding anything here. We'll keep going down the line. 5x, well, again, no counterpart. And lastly, we've got 1 plus 4. Well, that gives us 5. Alright, and then I want you to do this part right here. Use the dictionary to find the meaning of ascending and descending. Write their meanings, then describe a situation in your everyday life that relates to those two meanings. So just try to put it into words for me. Try to show me that you understand it a little bit. It'll help you more than anything else. That's an exercise for just you. Alright, I'm going to try to speed along here. So here we go. We've got adding and subtracting polynomials. So we're going to try to make sure they're in standard form. I want you to finish reading this up. Polynomial or monomial. It kind of just goes through this. Polynomial or monomial, binomial, trinomial. So kind of a little bit of a review of what we've talked about. Okay. Down here we've got from greatest to least. That's called standard form. Alright, this exercise we're going to determine whether each expression is a polynomial. If so, state it monomial, binomial, trinomial. Okay, then find the degree of the polynomial. So we see down here we've got two expressions. Alright, it's the sum of two monomials, so we call that a binomial, and the degree is 3. So you can see there's 3 variables, 1, 2, 3. Those 3 variables each have an understood 1. When you add them together, that makes the degree 3. Alright, negative 25. Well, yes, it is a polynomial, but it's just a monomial, because it only has one expression, and there's no degrees because there are no variables. This one right here, that's a big old no. No, it's not. It's not a polynomial because when you have a negative exponent, it actually turns into a fraction. We flip it and it becomes a fraction. That makes it not a polynomial, not even a monomial. So it's none, and there's no degree. Right here we got a big problem. Alright, yes, it is a polynomial. Alright, we can simplify it a little bit, so combine it. That's what it says right here. 9x squared to 7x plus 4. So you see how 4x plus x plus 2x, you can combine those before you label it. It's a trinomial then. Degree of 3, because again right here we've got x cubed. Alright, so we'll look down here again. I've got these done for you. You can maybe pause the video and look at these, but you can kind of see just quickly. Yes, these are, 36 is a polynomial. Yes, this is a polynomial. No, this is not. There's a fraction there. No, this is not. There's a fraction there. Yes, yes. Then, if you look at the degree, it's 0 because there's no exponent. 1 because it does not have any exponent there, just that understood. These don't need anything else because they're no. And then here this is 3 because again you've got g cubed and then h to the power of 1, that understood 1. And then here it's 2. You can see for yourself the reason why on that. Then of course that's a monomial. This has 2 expressions because you can simplify 7x minus x into 6x before you label it. Then here you've got boom, 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 3 and 2, so try and buy. Then here we're going to write this in standard form. Super important to learn how to write into standard form. So standard form is big. We want to go in descending order from greatest to least. So here you just switch it around. You put x to the 5th, then x to the 3rd, then x squared. Here you're going to put x to the 8th first, then x to the 7th. Over here you see, oh man, there's an x to the 5th, that goes first, then x to the 4th, that goes second, then x to the 3rd, that goes third, and then you come all the way around to 1, and that goes last. So you see what we're getting at. That's in standard form, and whatever number's in front, so we can see, we have eyes, right? That understood 1 being in front, or maybe understood -1, that's what we identify as our leading coefficient. So whatever number ends up in front of the highest degree, that's what we're going to call our leading coefficient. If you have some questions, I'm here for you to ask, but just go ahead and see if you can finish working on those. Then we'll look over here at a couple of examples, and I'll give you your homework, or what you're supposed to do. So now we're getting into the actual process. I know it's a long introduction because we didn't know any of this stuff before we got here. I'm not even going to tell you about the horizontal method. I feel like this is going to be a lot more confusing to most of you if you try to do it this way. I don't really like it, but hey, if you like it and that just works for your brain, absolutely do it. I personally think that this vertical method is the one that makes the most sense. It's how we learned to do most of our adding once it got to more complex adding, so I think we're going to be a lot more used to this. So when we look at a problem here, like 4a minus 5 plus 3a plus 6, okay, how do we get to our final answer when we add it? Well, we write it out and we stack it. So you'll see we put 4a minus 5 over 3a plus 6. Well, when we put those there, then you can see that I kind of sectioned it off. I mean, it's pretty much you line it up and you say, okay, these are going to be added together, 4a and 3a. I'm going to add those together. Then these two are going to be added together, -5 and 6. So it's just simple addition from there. 4 plus 3 is 7. Hold on. Let's do green. 4 plus 3 is 7. And then -5 plus 6 is +1. Or you could flip that around in your mind and do 6 minus 5 is 1. Okay? then we end up with our final answer of 7a plus 1. That's what we have left over down here. Now, if we're adding here, I've already done some of this work, but let's see if we can look through it. Alright, so like I said before, whenever you've got a negative here, so in this problem I kind of showed you, you're going to carry this 1 or distribute this negative 1 out to the different terms here. If we were going to change this, it's basically we're going to change all the signs. If they're negative, make them positive. If they're positive, make them negative. And then we can treat it like addition, because it's easier to add in our minds than to kind of go back and forth between subtraction and addition. Do I have to switch it? I like to set that up ahead of time, do my thinking, and then make it real simple at the end. So negative 6p squared becomes positive 6p squared. Then positive 6r becomes negative 6r. Then negative 3 becomes positive 3. Okay, that's how we would do it. In this problem here below that I already wrote out, when I multiply these, I end up with negative 3x squared and negative 5x and positive 1. So I lay these all out, and I've now put them in their lanes. So you can see here, I had the negative 3x. You know what, let me erase this a little bit here. That way we can kind of see what's... Alright. Alright, so we've got, I put the second answer, the second one on top, so it's negative 3x minus 5x. I'll highlight as I go along. Negative 3x minus 5x plus 1. Negative 3x squared minus 5x plus 1. That's what I put in that lane. Then my second one, I didn't have to change at all right here. 3x squared minus 2x. Doesn't have anything over here, but that's okay. So now that these are in lanes, I pretty much just have to add to get to my answer. Well, you'll notice that negative 3x and positive 3x are exact opposites of each other, so they're going to cancel out. Then we've got negative 5x minus 2x, and that gives us negative 7x. Then we've got positive 1, not added to anything else, so that's where we get our answer, negative 7x plus 1. And you can come over here and kind of see that's exactly what I do again. There's another addition and another subtraction problem. You can look and see that's what I did here. Pause the video, take a look. Again, if you have some questions, go ahead and let me know. Now let's go over to this last page, and I'll show you what I want you to do. Just know there's 10 questions, so they're going to be worth 5 points each. So I want you to find the sum difference of 1, 2, 3, and 4. Determine whether each expression is a polynomial. If it is, find the degree and determine whether it's a monomial, binomial, or trinomial. That's like on this page right here. Exactly what we did right here. And then on the bottom, write each polynomial in standard form. Identify the leading coefficient. That's 17, 18, 19, and 20. Okay, those are the 10 I want you to do. Make sure we get those done. And if you have any questions, I'm right here to help you.